In this straight chem session, we're going to learn about the 7 enthalpies for thermochemistry. We have formation, combustion, atomization, bond dissociation energy, neutralization, hydration, and solution. We have to learn all of the definitions of these enthalpies, and it's very important for you to know that there are 2 important keywords in all of the definitions for the enthalpies. Number 1, you need to know what happened to the heat. Either it's going to be heat change, or heat being absorbed, or heat being released. And something in the enthalpies over here will be kept at 1 mole. Okay, so 2 keywords that you need to focus on. You need to know for all of the enthalpies that we need to learn in this video. First, we have to look at the enthalpy of formation with the symbol of change, enthalpy formation. Remember, the triangle symbol over here denotes change, H for enthalpy or heat, okay? So H is the shorthand notation for enthalpy, and F over here, formation. Now, the enthalpy of formation, delta HF, is defined as the heat change, okay? So it is the heat change. You cannot put heat absorb or heat release, because all of the formation reaction, all of them, they might going to have heat release or heat being absorbed. So that's why for enthalpy of formation, you have 2 possibilities. Either it's going to be release or absorb. And that's why in the definition, we're going to use the word heat change. Okay, so it's important for you to know that you're going to use the heat change and 1 mole. So what is the thing that we're going to keep at 1 mole? So this thing, it needs to be at 1 mole. If it is not 1 mole, therefore it is not going to fit into the definition of enthalpy of formation. So the thing that we're going to be keeping at 1 mole for this enthalpy is the compound form. Okay, so the compound form in the example here is H2O. When you look at the number of mole, it's 1 mole. Okay, so that one needs to be 1 mole, and the heat needs to be changed. So you have heat being released. In this case, you have negative sign. Okay, so that is the heat change. So in this case, you have so that is exothermic. And then the compound form is kept 1 mole based on the definition. And the H2O here, H2O liquid, needs to be formed from its elements, okay? From the elements. So the elementals are H and O, all right? So you have H and O. So that is the enthalpy of formation. So what happened if you have, because we can surely have the equation to be written in this form. You have 2. Okay, what if you have 2H2 gas plus O2 gas, and here you have 2H2O liquid. So what happened if you going to times 2, because you have half mole of oxygen over here? It's quite a normal thing if you wanna have it not in a form of fraction. You're gonna multiply by 2 for this one, and you get another balanced equation. So this one is balanced as well. okay, with the delta HF, of course. So is this still going to be enthalpy of formation? The answer is not, okay? So the one that we have here, the one that I'm highlighting in red, that one over here, is no longer this, okay, is no longer delta HF, okay? It's no longer going to be fitting in the definition of enthalpy of formation, because right now, when you look at the compound form, we have 2 mole compound being formed, okay? In the enthalpy of formation, it's important for you to have 1 mole of compound is formed from its elements, okay? From the elements right here. Okay, so what about if you have the word standard, okay? What happened if you have the word standard enthalpy of formation? It's going to be the exact same definition, the heat change, okay? So you have the heat change, 1 mole of compound is formed. So the compound 1 mole over there is being formed from its elements. So you have element H, element O right there. But this time, if you look carefully here, for the definition without the word standard in front, it will be under, okay, under stated condition, because this one is just for enthalpy of formation. But when you have the word standard enthalpy of formation, this time you have to include and you have to mention standard condition, which is 298 Kelvin and 1 atm. So this is the difference when you have the word standard and without the word standard. The rest of the thing is still going to be the same. The standard enthalpy for any elements is almost stable states, and it's going to be 0. Therefore, if you are required to have the standard enthalpy for oxygen or chlorine, how you're going to form that, it's always going to be equals to 0. So you have to remember this, because usually they can use this kind of statement to give it to you, and you need to know that for the formation of elements, okay, of elements, O2, Cl2. So these are the elements, okay, so that is elements, and that one is also elements. What else? We have Br2, we have F2, we have H2. All of this elements, okay, they have, okay, all of them will have delta HF, okay, standard enthalpy equals to 0. Now let's have a look at the second enthalpy, which is the enthalpy of combustion, delta HC. So the word combustion over here, you have to get to know with the word. So the word combustion over here refers to, you want to burn something, okay? You want to burn in oxygen gas, okay? So combustion means you are burning something in the presence of oxygen. So the enthalpy of combustion, if you look at what happens to the heats will release, because when you burn something, you will feel the heat, because when you burn something, it will release heat. So if you compare with what we had in here, okay, for enthalpy of formation, the heat is change, okay? You're going to put heat change because not all of the reaction will be releasing heat. Not all of the formation reaction will be absorbing heat. However, when you look at the combustion, okay, when you burn something, all of the combustion process will be releasing heat. we do not have, okay? You need to remember. So by logic, okay, we do not have cool combustion. So you have to remember that. If you think logically, do we ever have something that is burning that will feel cold or feel cool? No. So that's why we have to emphasize on the heat release. Okay, for combustion, it's always going to be releasing of heat. So you have here, this one is going to be exothermic reaction, releasing heats. And what will be kept at 1 mole? When you look at formation will say that 1 mole of compound is being formed. But for combustion, this 1 mole will be referring to the substance that is completely burned. So it will refer to this. So this thing over here needs to be kept at 1 mole. So whatever going to be burned, okay, whatever going to be burning over here, so that one needs to be kept at 1 mole. And it's important, okay, very important for you to include the word excess oxygen. You have excess oxygen. That oxygen over here will be in excess. And you're going to be making carbon dioxide and water steam when you burn this, okay? So for the enthalpy of combustion, it will be heat being released, and 1 mole of substance is completely burned in excess oxygen. So it's very different from what we have seen for enthalpy of formation just now. So that's why I said it's very important for you to focus. Okay, you're going to focus on the 2 keywords that I have shown to you just now. Okay, you need to look at what happens to the heat, and you need to look at what stuff that will be kept at 1 mole. So looking at the standard enthalpy, so it's going to be the same as what happens to the enthalpy of formation. The heat is still being released. Okay, 1 mole of substance is completely burned. That is still the same. Okay, you have excess oxygen, but this time it's important for you to write under standard condition, which is 298 Kelvin and 1 atmospheric pressure. So when the question asks you to write the definition for standard enthalpies, you have to include this standard condition. If the question just gonna write or going to ask you to write the definition for enthalpy of combustion without the word standard in front, it's enough for you to write under stated condition. Okay, so you have stated condition because it's just going to be enthalpy of combustion, and this one is not standard. And if you realize, I'm going to highlight it over here for enthalpy of combustion right there. Okay, if you look carefully at that symbol, you have delta HC. Okay, but when you look at the symbol for standard, you have delta HC and you have the symbol for standard. So that is the symbol for standard. So when you have the circle on top over here, that is the indicator for standard. Okay? Now, the third one, enthalpy of atomization with the symbol change in enthalpy. Remember, H stands for heat. Heat is the same as enthalpy, and the A over here is for atomization. So from the name itself, you can imagine that this enthalpy process is going to explain about how you're going to change from a molecule and you want to change that into atoms in the end. So again, when we talk about enthalpy, we have to think about what's going to happen to the heats. For atomization, because you want to break the bonds between the atoms in the molecule. You want to break them and you want to change them into, single atomic species in the form of gas. Okay. So when you want to atomize something, when you want to turn some molecules or you want to turn some huge lump of metal like what we have over here into atoms, you need to get the system to absorb enough heat and they can break all the bonds inside and you will start to produce the atoms that you want. Therefore, what we need to have for the heat to be doing is to be absorbed. Okay, so the system needs to absorb the heat to make 1 mole. Okay, when 1 mole of gaseous atoms is formed. So you have 1 mole of here going to be formed. So that is the bits that you need to cap at 1 mole. And the heat, when you look there, will be absorbed. So when you have heat absorbed, this is again endothermic. Reaction. Okay, so you want to absorb the heat. So remember sodium here, you have all the sodium in solid phase. They are very closely packed with one another, but once you start to give quite a lot of heat, okay, if you give quite a lot of heat, then the metallic bond between the sodium metals over here will start to break and you will start to be producing and all of the sodium gas will start to break off from one another and you're gonna get your atoms. Again, in this case, as you can see, it's just going to be enthalpy of atomization. Therefore, it will be under stated condition. Okay, so that is the elements right here. Again, for standard, it's still going to be same. Heat absorbed, 1 mole of gaseous atoms is formed, but this time you have standard condition. Okay, so you have standard condition, which is 298 Kelvin at 1 atmospheric pressure. Next one is the enthalpy of neutralization. So this is quite popular when it comes to calculation and problem solving, of which we're going to have a look at another video. Okay, so you need to know what does it mean by enthalpy of neutralization. You have seen neutralization process in the practicals that you have done maybe in the past and also in previous chapters, ionic equilibria, but what does it mean by enthalpy of neutralization when it comes to thermochemistry? So the enthalpy of neutralization is also going to be written as the heat change, okay? Because sometimes you have neutralization process that will be absorbing heat, and sometimes you have neutralization that will be releasing heat. The examples that we have over here is heat being released, okay? So over here you have the example of exothermic. But do remember, if you have the word heat change, you have to remember sometimes you have exothermic or endothermic. It all depends on what type of acid and base you're going to be mixing together, that's when you're going to get either exothermic or endothermic reaction. Having said that, 1 mole over here is going to be for the water is being formed. So you need to make sure for enthalpy of neutralization, you need to make sure that this water here will be 1 mole. If you do not have 1 mole of water, it will not going to fit in the definition of enthalpy of neutralization. Okay, from the neutralization of what? From the neutralization of acid and base under stated condition. Okay, stated condition because it's just enthalpy of neutralization. So what happened if you have standard? Again, you have heat change is the same. Okay, you have change of heat and 1 mole of water is being formed. You have 1 mole of water being formed over there. All right. And this time you have acid and base. You have acid and base, standard condition. Okay, so that is the difference between standard and non-standard. It's just the last bits of the definition. You're going to change that from stated for the non-standard and standard condition 298 Kelvin at 1 atm for the standard condition. 4 done and 3 more to go for the enthalpy. So let's take a break and let's have a look and let's have a try at a very short chem challenge over here. Now, what kind of enthalpies are these thermochemical equations? Okay, we have half mole of Cl2 gas to have Cl gas right over here, and you have the enthalpy. You have 2 mole of iron solids to be reacting with 3/2 moles of oxygen gas to produce Fe2O3. And you have an acid, and you have base. You have the salts and water being produced, and also you have the enthalpy value at the back. So all of these are the thermochemical equations. And you have this, you have carbon solid plus oxygen gas and CO2 gas. Okay, so let's have a try, okay? So the one there on top, number 1. So which enthalpy is this? Is it formation, combustion, atomization, or neutralization? When you look at the process over here, you have heat absorb. Okay, you have heat absorbed. Okay, you have heat absorb over here. Okay, so that is the heat being absorbed. So this is endothermic. And you have 1 mole of that being produced. Okay, so that is 1 mole from the elements. So this is the, okay, so this is the enthalpy of atomization. Okay, so number 1 is the enthalpy of atomization. Why is it not standard? Because when you look at the symbol over here, you do not have the small circle on top, so that's why it's not a standard enthalpy of atomization. Okay, what about this? Okay, what about the one that we have over here? If you think this is going to be combustion, you are incorrect. Okay, what you think is incorrect. Why? Because based on definition of combustion, this thing over here, the one that you want to burn, okay, the one that you want to burn needs to be 1 mole. If you go back to combustion very quickly, okay, so we look at combustion, the heat released when 1 mole of substance is completely burned. You need to have the thing that you need to burn in oxygen to be at 1 mole, okay? But what you have there, you do not have 1 mole of iron being burned in excess oxygen to make these. So what enthalpy is this one? When you look carefully, you have 1 mole of product. Okay, you have 1 mole of this being produced. So that one is 1 mole. And when you look on the other side, this is 1 mole, and your Fe2O3 is being made from its elements. So these are the elements. So you have oxygen elements, you have iron elements. Okay, these are not elements. Okay, so these are molecules. These are elements because inside this you only have oxygen. Inside this you only have iron. So you have 1 mole of product being formed, compound being formed, and you have the heat change right there. And Fe2O3 is formed from its elements. Okay. So I'm going to highlight that. Those are the elements. Okay, so I think this one is fitting into the definition of enthalpy of formation. So the heat change when 1 mole of compound is formed from its elements under stated conditions. So you have 1 mole. Okay, you have 1 mole over here. Go back to the exercise. You have 1 mole of Fe2O3 being produced from its elements. Therefore, the second one is, this is the enthalpy of formation. Okay. The third one that we have here, this one is very obvious. You have acid, you have base, and you have 1 mole of water being produced. Okay, you have 1 mole of water being produced. You have the acid and base. Okay, this is the acid. That is the base. And you have 1 mole of that. And you have the heat change. Therefore, this is enthalpy of neutralization. The last one that we have, you have carbon reacting with oxygen to produce carbon dioxide. Okay, for this bit, you have heat change over there. You have heat being released. Okay, you have, that is exothermic. So what about this one? You have 1 mole. That one is 1 mole. You have the elements. Okay, you have the elements here. Those are the elements. What could it be? Okay, you have elements. So this bit, we can have 2. Okay, number 1, for this part over here, it fits into 2 enthalpies. Number 1, it fits into enthalpy of formation. Okay, why? Because you have 1 mole of compound being formed. Okay, you have 1 mole of compound over there being formed. So over here you have 1 mole. And you have that CO2 being produced from its elements. So it fits into the definition of enthalpy of formation. Also, it fits into the enthalpy of combustion. So it can have both. Okay, so this reaction that we have over here can have both types of enthalpies. Why combustion is still okay as well? Because when you look at that part, when you look at the part over here, you have 1 mole of carbon solid being burned. Okay, so you have 1 mole of over here as well. You have 1 mole of that as well. Burn in excess oxygen to make carbon dioxide. So that's why this one can also be enthalpy of combustion. Now we're going to look at the enthalpy of hydration, and the symbol for enthalpy of hydration is change in enthalpy, hydration. So for the enthalpy of hydration, we are going to be focusing on the heat being released when you have 1 mole. So what is that 1 mole of gaseous ions? You have gaseous ions being added into water under stated condition. So we have the 1 mole of ions hydrated in the water. For the standard enthalpy, so when you look at the standard enthalpy, so it's the same as what we have looked at for the other 4 before we reach this point of this video. When you have the word standard in front of the enthalpy, you're just going to change the stated condition into standard condition right here. Okay, so standard condition is the same, which is 298 Kelvin and 1 atmospheric pressure. Still, the heat's going to be released for hydration, and 1 mole of gaseous ions added or hydrated in water. You have 1 mole of gaseous ions, so that is the example of gaseous ions. So this and that, those are the 1 mole gaseous ions. And these ions over here in the form of gas, as you can see over there, will be hydrated, meaning to say you're gonna dissolve this or hydrate this with H2O, and now you have Na plus aqueous. So note that the change in phases from gas into aqueous. You have from gas into aqueous because over here we have got the Na plus added with water already. So this is what it meant by enthalpy of hydration. You have 1 mole of gaseous ions hydrated in water to have this, and the heat will be released. So the heat for hydration will always going to be, okay, so it's always going to be an exothermic reaction. All right. Slightly different, and sometimes students gonna mix this up with enthalpy of hydration, is the enthalpy of solution. Enthalpy of solution refers to the heat change, okay, the heat change just now. For enthalpy of hydration, it will be heat being released. So right now, for enthalpy of solution, you can either have heat's been absorbed or released. So that's why we're going to use the word heat change, because the process of making a solution, depending on the type of compound that you have, it may be exothermic, it may be endothermic. So now the heat change, okay, in this case over here you have endothermic, and note that I said you can have exothermic because we are focusing on heat change. So the thing that we're going to keep 1 mole for enthalpy of solution is the substance that you're going to be dissolving inside water under stated condition. So that part over here, okay, so this bit over here needs to be 1 mole, okay? And if you look at the phases from solid, all changes to, it will dissociate it into the ions, okay? Because these are ionic compound. And when you dissolve that in water, you have K plus aqueous plus Cl minus aqueous. But the most important thing over here is you need to remember, for enthalpy of solution, we're going to focus on 1 mole of your ionic substance over there. So when you have the word standard, again, you have word standard, you're just going to change that into standard condition to 89 Kelvin and 1 atmospheric pressure. Okay? Now, the last one for this video is about bond dissociation energy, or BDE, okay? So bond dissociation energy is defined as, the heat change. Sometimes you need to absorb heats, sometimes you need to release heats. In the example that we have over here, the bond dissociation energy happens to be an endothermic process, okay? And you need to keep what at 1 mole? You have 1 mole of bond to be broken. So inside your Cl2, if you expand this, you have Cl and you have 1 bond connecting both of the Cl. So over here, you have 1 mole of bond, okay? Over there, you have 1 mole of bond. And you're going to break this bond. And when that bond breaks, you have 2 free radicals over there, okay? So you're going to be making over here 2 free radicals. So that is the definition of bond dissociation energy. The heat change when 1 mole of bond is broken through homolysis under stated condition. And again, it's the same thing. When you have the word standard, then you need to change under standard condition 298 Kelvin at 1 atmospheric pressure.